All right, today we are diving deep into the hidden science that honestly keeps our world from being buried in its own trash. This is the science of waste characterization, and it's this really fascinating field where scientists basically play detective to figure out exactly what's in our garbage and, more importantly, how to deal with it safely.
So you toss something out, but what happens after that? Well, that simple question kicks off a whole journey into some pretty rigorous scientific testing. The whole point is to draw a bright, clear line between what's just harmless garbage and what's genuinely hazardous stuff. And this isn't just about ticking boxes on a form, it's the critical process that protects our water, our air, and our health. So let's get into it.
So, here's how we're going to break down this whole investigation. First, we're going to meet the 4 official characteristics that can make waste dangerous. Then, we'll step into the lab for a test that cleverly simulates what toxic rain would do in a landfill. After that, we're going to ask if trash can actually be treasured by measuring the energy that's locked inside it. And finally, we'll take a little peek into the future to see how scientists can predict how waste is going to behave over the long run. Okay, so according to regulators like the EPA, waste gets officially slapped with the hazardous label if it has at least one of 4 very specific traits. Let's think of them as the 4 faces of danger. If a waste shows any of these, it needs special, very careful handling. First up is ignitability, and this one is pretty much exactly what it sounds like. Can it catch fire easily? We're talking about anything with a flash point below 60 degrees Celsius, that's about 140 Fahrenheit. This is the kind of stuff that poses a really serious fire risk, whether it's being shipped, stored, or just sitting in a landfill.
And you'll definitely recognize some of these. Things like waste oils, certain kinds of paints, and used industrial solvents. They all fall into this category. Every single one has to be managed with extreme care because of that constant threat of catching fire. Next, we've got corrosity. This one is all about chemistry. A waste is considered corrosive if it's a really strong acid with a pH of 2 or less, or a really strong base with a pH of 12.5 or higher. This kind of material can literally eat through steel drums or cause pretty nasty chemical burns if it touches your skin. So, what are we talking about here? Well, think battery acid, which is super acidic, and some of those industrial-strength cleaning solutions, which are often the exact opposite, highly alkaline. The key thing to remember is their powerful ability to just dissolve and destroy other materials they come into contact with.
The third face of danger is reactivity, and this applies to waste that is just unstable. It might explode under normal conditions, it could react violently if it gets wet, or it might release poisonous gases. This is the unpredictable, volatile stuff that really keeps scientists on their toes.
Yeah, this category includes things you really do not want to mess with. Pure sodium metal, which literally explodes on contact with water, and cyanide-bearing wastes that can release deadly hydrogen cyanide gas. What makes these materials so hazardous is their sheer built-in instability.
And finally, there's toxicity. Plain and simple, this one is about poison. A waste gets classified as toxic if it's got specific harmful chemicals that could leak out, contaminate the environment, and make people sick. And to figure that out, scientists use a very specific and actually pretty clever test.
So that brings us to a huge question. How do we actually know if some waste that's buried in a landfill is going to eventually poison our groundwater? Well, the answer lies in a lab procedure that's designed to mimic in just a few hours what might happen out in the real world over decades.
Scientists have 2 main ways to run this simulation. The first one, the TCLP test, mimics a typical landfill by using a weak acid, kind of like vinegar, to act like the juices from decomposing garbage. The other one, the SPLP test, simulates what happens when waste is exposed to acid rain. It's kind of like testing coffee grounds. First you run regular water through them, but then you try running something much harsher through to see what else comes out.
So let's focus on that landfill test, the TCLP. It's a really precise 4-step process. First, scientists pick just the right acidic fluid. Then, they tumble the waste and the fluid together for 18 hours straight. This is what simulates years of liquid slowly trickling through a landfill. After that, they filter out that liquid, which now has a name, leachate. And finally, that leachate is analyzed for a list of 40 specific toxic chemicals. This right here shows you what it means to fail that test. If that leachate liquid has more than 5 milligrams per liter of lead or just a tiny 0.2 milligrams per liter of mercury, the original waste is officially classified as toxic hazardous waste. And the limits are incredibly strict, for a very good reason, to protect our drinking water sources from even the tiniest bit of contamination.
But hey, not all waste is just a problem we have to manage. Some of it actually contains a really valuable resource, energy. And that raises a whole new question. How do we measure the fuel potential that's locked away inside our trash? The amount of energy, or what scientists call calorific value, in some waste is actually pretty shocking. A kilogram of dry wood has about 14.4 megajoules of energy. That's a lot. Coal has more, around 21. But look at PVC plastic, a really common waste product. It packs a staggering 38 megajoules per kilogram. That's way more energy than wood and even more than some types of coal. This is exactly why waste to energy is such a big deal.
So to measure this energy with pinpoint accuracy, scientists use a device with an amazing name, the bomb calorimeter. They take a tiny sample of the waste, place it in a sealed steel container called the bomb, fill it with pure oxygen, and then ignite it. It's like a tiny, perfectly contained explosion. And by measuring exactly how much the water surrounding the bomb heats up, they can calculate the precise energy content of that waste.
Okay, so beyond the immediate dangers or its potential for energy, we need to know how this waste is going to behave over the long term. Will it break down, and what will it produce as it does? This brings us to the element at the heart of it all, carbon.
The key measurement here is something called total organic carbon, or TOC. This is basically a measure of all the carbon that came from something that was once alive. Like food scraps, paper, yard trimmings. The way they figure it out is pretty straightforward. They measure all the carbon in a sample, and then they just subtract the inorganic carbon. That's the carbon you find in things like minerals and rock.
So, why does TOC matter so much? Well, a high TOC means there's more food for the microbes in a landfill. And as they munch away on that waste, they produce more landfill gas, including methane, which is a really potent greenhouse gas. That decomposition also creates acids that can help dissolve toxic heavy metals, letting them seep into groundwater. So yeah, measuring TOC is absolutely essential for safe landfill design and management.
When you step back and look at it, all these tests, from checking flammability to measuring organic carbon, they are so much more than just bureaucratic hurdles. They are the essential scientific tools that let us manage our waste safely and protect our environment for the future.
This science isn't just an afterthought. It's the absolute foundation of modern environmental protection. Without this kind of careful, methodical analysis, we'd really just be guessing. And when you're talking about hazardous waste, guessing is how you get disasters.
It really makes you think, doesn't it? Every single thing we discard has a hidden story, a chemical makeup, an energy potential, and a future impact on the world. The science we've just looked at is how we learn to read that story. So the real question is, what story is our trash telling?
Thanks for tuning in.